Now we're going to learn how to solve by elimination when none of the variables have the same coefficient. So we can't just add them together, and we can't just multiply through by a negative. Taking a look at our first example, we have a 3x and a 1x, and we have negative 5y and positive 3y. Neither one of those are going to just add together to cancel, and they're not opposites. So what we do is we try and find a common multiple, something that both of the coefficients will go into. Our x variable will be easier to cancel because one of our x's has a coefficient of 1. If I multiply that 1 by a negative 3, it will be the opposite of the coefficient in the first equation, and then when I add them together, they'll cancel. So I'm going to rewrite the first equation. I'm going to follow the golden rule on that second equation and multiply everything by a negative 3. The negative 3 times 3y will give me negative 9y, and negative 3 times 4 gives me negative 12. Now when I add my equations together, my x's will cancel. I get negative 14y equals negative 14. So to solve for y, I'll divide both sides by negative 14. To get y equals 1. Solving for x, I will take either of the original equations, not the equation that I changed, one of the original ones. I'll use the second equation, x plus 3, replacing y with 1 equals 4. So we have x plus 3 equals 4, and subtracting 3 from both sides, we get an x value of 1 as well. My solution is 1, 1. And I will check that in the first equation by replacing x with 1, replacing y with 1, and checking to see that it equals negative 2. 3 times 1, 5 times 1, and 3 minus 5 is negative 2, so my answer checks out. Taking a look at a word problem, the question said, how much did the shoes and scarves cost? So those are going to be my variables. Shoes and scarves both start with an S, so I'm going to say H is the cost of the shoes. I don't like S as a variable, it looks kind of like a 5, so I'm going to say C is the cost of the scarves. All right, I will need an equation for Riley and a separate equation for Carson. Riley bought 3 pairs of shoes plus 2 scarves, and her total was $70. Carson bought 2 pairs of shoes and 4 scarves for a total of $60. Taking a look at my 2 variables, 2 does not go into 3, so I can't multiply 2 by something to make it cancel with my 3. But looking at the scarves, 2 does go into 4. If I multiply this top equation by negative 2, I will get the 2 times negative 2 to cancel out with the 4 in the second equation. Distributing that negative 2 to everything in the first equation, including that 70. I'm going to leave the second equation alone. And when I add these equations together, my negative 4c plus 4c will cancel, and I'll be left with negative 4h equals negative 80. Dividing both sides by negative 4, I get the cost of the shoes is $20 each. To solve for the cost of the scarves, I will take either of the original equations. I'm going to use the second one because it has smaller numbers, substituting 20 in for h, multiplying the 2 times 20, subtracting 40 from both sides. 4c equals 20, so when I divide both sides by 4, I get the cost of each scarf was $5. And checking my solution in the equation that I did not use to determine the cost of the scarf, I'm going to replace h with 20. I'm going to replace c with 5 and check to see that this totals $70. 3 times 20 is 60, 2 times 5 is 10, and 60 plus 10 is 70, so my solution checks out. Once again, a couple of you try questions if you're comfortable. If you feel like you need some additional support, we'll go over those last two examples in class.